Okay, so a number of you missed this one. This is a little bit tricky. This is number 21. It says find the least common multiple, or the LCM, for 4, 19, and 38. And what that means is if you count by 4s, and then you count by 19s, and you count by 38s, at what number will they all end up on? Okay, there is one way that I've taught you in the past, and I like this method, but for this particular one, it's a little bit tricky. So I like to just do 419. You can put all three numbers in there. We're going to do kind of like the ladder method. And what the ladder method is, you have to look for a divisor that's a prime number. So 2 is a prime number. 2 goes into 4 2 times. 2 does not go into 19, so I'm just going to leave that alone. I'm just going to bring that right straight down, keep it the same. Okay. And then I'm saying, does 2 go into 38? Yes, it also goes 19 times. Okay. And then I'm going to divide again. And I'll say, do I have any prime numbers that go into 2, 19, and 19? I have to think to myself, well, 2 is a prime. 2 goes into 2, but it doesn't go into 19, doesn't go into 19. Is 19 a prime? Well, actually, yeah, yes it is. So we're going to divide by 19 here. And 19 does not go into 2, so we're going to keep it the same. 19 does go into 19 how many times? Once. And 19 goes into 19 once. And then we're done. Okay? So what you can do with the LCM is sort of just go straight across, if you remember this kind of idea. 2 times 19 is 38, times 2 is 76, times 1 is 76, times 1 is 76. So the answer was 76. Okay. The other way would have been to list out all the multiples, 4, 8, 12, 16, 20, all the way up and keep going. That might take you a long time. And then do 19s, 19, 38, 57, and then 76, right? And then if you had 38, count by 38, so you have 38, 76, and lo and behold, here's a 76, and here's a 76, and sure enough, 76 is divisible by 4. So 76 is your least common multiple. Okay, so this was a tricky one, and a number of you missed this one. The question was, what was 1/2 of 1/5 is 1/3 of what number? So we have to do some decoding here. So that's easy enough. 1/2 is 1/2. Of we know is multiplication. 1/5 is 1/5. Is an equal sign. 1/3, of course. Of is multiplication of some number. Let's call it n. Okay? So if we solve for this side, 1/2 times 1/5, we can do that easily, straight across. 1 times 1 is 1, and 2 times 5 is 10. So this is 1/10 on this side is equal to 1/3 n. Remember, anytime you have a number that's next to a letter, it means multiply. So that's why I'm not putting the x in there. Now, to get rid of a fraction on one side, you have to use, which is really division. It really means 1 divided by 3. To get rid of that, you're going to multiply by the inverse. So this is really the same as saying multiplying by 3 over 1. So if we multiply by 3 over 1, we have to do it to this side. So we're going to multiply by 3 over 1. So 3 over 1 is 3. 1 times 10 is 10, is equal to, this will cross each other out, is n. So your answer is 3/10. The other way you can think about this is saying, well, even if you weren't able to do this, you could say, well, 1/10 is equal to 1/3 of an n. So this is the same as 1/3. So what if we had 3 of those? 1/10, 1/10, and 1/10. That would be a third, a third, and a third, right? Which is the same as 3/10 is equal to n. Okay. Okay, here's number 23, and most of you got this one right, but let's just do it anyway. We're finding the greatest common factor of 16, 40, and 96, or the GCF, right? So you can set up the same way we would do with the least common multiple. So if you can do a 16, a 40, and a 96, we'll do the latter method, which I really like a lot. And you're going to divide by the first prime number that goes into all of them. Has to go into all of them. So the first one is 2, I know, because 3 doesn't go into that. So 2 goes into 16 8 times. 2 goes into 40 20 times, and 2 goes into 96. Well, half of 90 is 45, and half of 6 is 3. That's 48. Okay, now I'm going to try it again. Can I find a prime number that goes into 8, 20, and 48? Well, 2 again will go into each of those. So 2 goes into 8 4 times, 2 goes into 20 10 times, and 2 goes into 48 24 times. All right, let's try it again. Is there a prime number that goes into all 3? Yes, there is. It's 2. So 2 goes into 4 2 times, 2 goes into 10 5 times, and 2 goes into 24 12 times. Right? And I say, well, is there another prime number that goes into all 2, 5, and 12? And the answer is no. So I need to stop here. My GCF is right there. So 2 times 2 is 4, times 2 is 8. So 2 times 2 times 2 equals 8, and 8 is the GCF. All right, or the greatest common factor. So 8 will go into 16, it will go into 90, and it will also go into 96 evenly. All right, so that's your answer for number 23. Okay, number 24, again, another tricky one here. But it's not too bad. So let's see what it says. It says 2 boards were nailed together to make one long plank. One board measured 4 2/3 feet, and the other measured 5 3/5 feet. Okay, how long was the plank? So we have to add, seems like we have to add these up. So let's do it. So we have 4 2/3. And we're going to add that to 5 3/5. Well, when we're adding fractions, you know that we can't add fractions unless we have a common denominator. So we need to say what's the LCM, or the least common multiple, of 5 and 3. Count by 5s, 5, 10, 15. 3s can become 15 as well. So we're going to multiply this by 3, multiply this by 3. And up here, to get this to be a 15, we're going to have to multiply that by 5 and multiply that by 5. So that leads to 10 15ths, and this leads to 9 15ths, right? And so if we add these up, we get 19 15ths. And 19 15ths is an improper fraction. So how many groups of 15 can we get out of 19? We get 1, with how many left over? 4 15ths left over. But now let's not forget that we have to add up our whole inch, or our whole feet. 4 feet plus 5 feet is a total of 9 feet. So we have 9 feet plus 1 foot and 14 15ths of a foot. So for a total of 10 and 4 15ths feet. Okay, and that is your answer to number 24. Okay, so this is our last problem, and obviously you can see that it's definitely a distance, rate, and time problem. So if it takes a car 44.3 hours to travel 240.5 miles, what's its speed? Okay, so as you recall, the formula for problems like this is distance equals rate times time, or as I like to say, dirt, way of remembering it. So let's begin to plug things in. So if D equals R times T, let's take D. So we have 240.5, and that's going to equal rate times time. Now we don't know the rate, but we know the time. So let's put 4.3. We'll call it R. So remember, when a letter is right next to a number, it means to multiply. All right, so we want to get our R by itself. So to do that, we're going to divide by 4.3 on this side of the equation and 4.3 on this side of the equation. All right, So let's go ahead and do that. Move this up a little bit. All right. So we have, let's see, 240.5 divided by 4.3. Okay, and remember that if we have a decimal point in our divisor, to move that over. And if we move it over in the divisor, we also have to move it over in the dividend. So our new problem is 43.2405. Okay, so we need to divide. So we take groups of 43. Can you get 43 out of 24? No, you have to go all the way to the 240. So the question is, how many groups of 43 can you get out of 240? And you can figure this out, but it would be about 5. So, and if I multiply 5 times 43 times 5, this is 15. All right, 5 times 4 is 20, 21. So we have 215. Subtract that away, and we're going to be left with 2. And we have to ask ourselves, how many groups of 43 go into 25? And we have 0, so let's bring down the next 5. And how many groups of 43 in 255? Well, I can see that it's going to be 5 again, because 43 went 5 times into 215, and it's not, I can't get another group of 43, so it's 5. 215, and we're going to subtract that, and we'll get 0, 4. Okay. How many groups then of 43 go into 40? 0. So let's put the decimal point here, and we'll add a 0 here, and then we can bring that down to 0. How many groups of 43 can get out of 400? And I'm going to guess about 9. So 43 times 9, 27. 9 times 4, 36, 38. So 387. And we do a little subtraction there. That's going to be, I know that's going to be 13. Okay, so I'll put my decimal point here, and I'll put a 9 up there. All right. So again, the question is, how many groups of 43 can get out of 13? You can't, so let's add another 0, and we'll bring this down. 0, whoops, a little hard to write this way. How many groups of 43 can get out of 130? And it's going to be 3. So 3 groups of 43 is going to be, if I simply multiply 43 times 3, it's 129. Okay, so, and then that's enough. This will end up being 1, but this is far enough. So its speed is 55.93 miles per hour. So that's your answer. Okay, that's number 25.